In this video, we're going to continue to talk about exponents, and we're going to focus on the product rule of exponents. So the product rule is written here for us. A to the m times a to the n equals a to the m plus n. Now that seems a lot scarier and more confusing than it really is. All that means is if you are multiplying two numbers with exponents, as long as those two numbers have the same bases, so in this case 3 to the second times 3 to the fourth has the same base of 3, it means you can just add the exponents to get your answer. So again, we're not solving, we're not going to work and find our final answer. We're just working to simplify these problems, okay? So here's our first example, 3 to the second times 3 to the fourth. Now I could write this out, right? We know 3 to the second means 3 times 3. And 3 to the fourth means 3 times itself 4 times. And then I could count up how many 3's I have. 1, 2, 3, 4, 5, 6, and get 3 to the sixth. But my product rule tells me that I can just add my exponents and get my answer right away. So if I wanted to use the product rule to make my life a little quicker, I could do 3 to the second times 3 to the fourth, knowing that if I just add these exponents together, I would get my new exponent, 3 to the sixth. Notice how my base does not change. My base is going to stay the same. It's the exponents that we add together. I'm not going to multiply 3 times 3. That's not what it's telling me to do. So let's try another example. If we had something like x to the fifth times x to the third, I could write this out, right? I could write 5x's times 3x's, and all together I could count them up and get 8x's. Or I can just add the exponents. 5 plus 3 is 8, so x to the fifth times x to the third gets me x to the eighth. All right, let's try another example. 7 to the sixth times 7 to the second, or sometimes I could say 7 squared if I felt like it. So I'm going to take my two exponents, which are 6 and 2, and I'm going to add those together. 6 plus 2 is 8, and it's 7 to the eighth. Notice how I did not multiply 7 times 7. That's not what it wants me to do. I'm just adding those exponents together, so I get 7 to the eighth. All right, let's try another example that has a little something different in it. I'm going to do 6 squared times 6 to the 0 power. Okay, 6 to the 0 power and 6 squared. So again, I'm following the same rule. That 0 looks a little funny. I might not know what to do with it, but really you're just doing the same thing. 2 plus 0 is just 2. So 6 to the second times 6 to the 0 gets me 6 to the second, or 6 squared. Okay, I'm going to erase a little bit and try some other examples. So here's another one that has some slight difference to it. We've got y to the third times y. A common mistake here would be to think you were doing 3 plus 0 when you're adding, because you don't see anything over here with the y. But if it were to be 0, it would be written like it was in the last one we just tried. So in math, when we don't see a number written there, it really means 1. So we have to count that y, because if I was writing this out, right, this would be y times y times y. And this one, we still have to count this y here. It didn't go anywhere. There's not 0 y's, there's 1 y. So for this one, I would add 3 plus 1 to get me y to the fourth. Okay. We can also do some more difficult problems that have more than 2 things being multiplied against each other. So let's try one that has 3 things in it. All right, so let's do x to the third times x to the fourth times x to the fifth. So it's still the exact same rule. All of the bases are the same, x, 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 which means we can just add our exponents all up to get our new exponent. So 3 plus 4 is 7, and 7 plus 5 is 12. So x to the third times x to the fourth times x to the fifth is x to the 12th.